Hello and good evening to everyone. I am Komal Patil, lecturer at IT department at Parul University. Today we have a webinar on the topic Knowledge Generation from IoT Networks, Possibilities in Fog and Edge Computing, delivered by Professor Viren J. Patel from Government Engineering College, Lahore. Professor Viren J. Patel carries a wide experience in theory of computation algorithms. Currently, he is pursuing his PhD degree on IoT. Now, I welcome to Professor Viren J. Patel, sir, on behalf of Parul University to start the session. Welcome, sir.
Thank you, madam. Thank you very much for the opportunity.
You're welcome, sir.
I'll start presenting now.
Yes, sir.
Hello, everyone. Welcome to this webinar. I'll be sharing my PPT, and in case I have to share other screen, I will change the PPT if I want to show you some live examples. This is a webinar regarding the topic mentioned as knowledge generation from IoT networks, possibilities in fog and edge computing. Now, knowledge generation is something which is very important and which is being done from many years. But it is not like formal knowledge. In this presentation, I will introduce you all, my listeners and viewers, to the concept of how these things can be made possible. First things are, we will look how existing cloud, fog and edge computing concepts work. And then we'll also see how presently these knowledge generation things are working. We'll see the examples and how IoT networks can contribute to all this kind of knowledge generation. So let's start. As I introduced to the presentation, ये सारे टॉपिक्स है जो हम कवर करेंगे, नॉट एक्सक्लूसिवली इसके सारे कॉन्सेप्ट्स हम कवर नहीं कर सकते, बट आई विल इंट्रोड्यूस यू टू हाउ दिस थिंग्स वर्क एंड ओनली पार्ट ऑफ इट नॉलेज जनरेशन इन वेब. तो ऑलरेडी जो आप डेटा अपलोड कर रहे हैं, इवन फ्रॉम योर सिंपल फोन, एवरीथिंग दैट यू राइट और एवरीथिंग इज दैट इज रिटन ऑन वेब is knowledge. But then in plain sense, it is only a data. The data has to be collected, it has to be structured, and if it is very well structured, it becomes knowledge or information. And then it is shared. And that knowledge or data has some value. The other concept, which is a technical concept, knowledge generation is a wide philosophical concept. ऐसा नहीं है कि even only इन कंप्यूटर साइंस और इंजीनियरिंग या फिर आईटी फील्ड की बात करोगे तभी नॉलेज की बात हो सकती है. नॉलेज इज इन ब्रॉड सेंस एवरीवेयर एंड इवन फिलोसॉफिकल थियरीज कैन बी गिवन. इट इज आउट ऑफ द बाउंड ऑफ द साइंस वर्ल्ड. लेकिन उसको अगर फॉर्मलाइज करना है, उसको अगर स्ट्रक्चर करना है, देन यू कम टू द लेटेस्ट टेक्नोलॉजीज विच इज गिवन बाय आर्टिफिशियल इंटेलिजेंस एंड मशीन लर्निंग. और वो on daily basis you are using it every second when you use Google. On the other hand, cloud, fog and edge computing are the technologies implemented which imbibes, जिसमें सारे technological aspects शामिल हैं, even the network, the small devices. We'll look into that also, and then we'll look at the possibilities of what can be done, how the IoTs can help to generate knowledge. So formal definition, you can find it on Google search. I'll use this word a lot, but of course you will find the same definitions. familiarity, awareness, or understanding of someone or something, such as facts, skills, or objects. Now, the search engines right now cannot give you whole sense of knowledge. Like the search engines can of course give you the knowledge that is already on web. But if the knowledge is not represented on web, it will be very hard to find it. If you ask certain questions that are not formally structured somewhere, not uploaded by someone, you will not find on search engines because they are based on text search and your past searches and everything. So this is the formal definition of knowledge which is applicable to globally. Another definition is defined as what is learned, understood, or aware of. The example is knowledge of learning an alphabet. And also ability to find a location. An example of knowledge is remembering details about an event. All these are different types of knowledge that we can have, or we can have the assistance of. Our present systems give us the assistance. When you ask a search engine to find the direction to certain location, it is giving out knowledge because that knowledge exists with it. That is an example of knowledge. There cannot be any doubts regarding this. Now coming to internet and World Wide Web. Having defined knowledge now, it was an understanding कि knowledge क्या होता है, और ये भी अंडरस्टैंडिंग चाहिए कि वी नीड अ लिमिट कि नॉलेज कहाँ एंड होता है, हमको कितना नॉलेज मिल सकता है, एंड देयर इज अ लिमिट टू इट. द इंटरनेट कैन नॉट प्रोवाइड यू एवरी नॉलेज like a simple knowledge to how to live a life. It is a difficult one, and if there are many results, it will be difficult for you to choose one also. Now coming to internet and the World Wide Web. So the students of Parul Polytechnic, all the students of engineering also, the basic definition is very clear that internet is the infrastructure. Every wire, switch, router, server, computers and storage. So internet is the infrastructure. When your phone gets connected to the internet, the hardware of your phone or the phone itself is part of the internet. You are generating data every second, and it is connected to a network, to some network, and that network again is connected to the other network, so it becomes the internet. So internet is the infrastructure part. Internet does not give us information. It is the mode, the medium through which we get the information. That way you can think. Because internet is everything. Even a car having a Bluetooth device that gives out the information to a mobile phone is part of a network now. That is why internet is growing, and that is how the Internet of Things term has come up. We'll go to that part. Let's go to World Wide Web part. World Wide Web is all the information on website. Please pardon me for the spelling mistake. World Wide Web is all the information on the website. The service over internet infrastructure. It is the website, content uploaded, text, graphics, sound, linked information, everything that you see on your screen is a part of World Wide Web. So every content that you upload, every image thing that you upload becomes a part of World Wide Web, because World Wide Web is a service of connected websites. Now, it should be easy to extract information from World Wide Web, but it is not done just without any efforts. World Wide Web में information होता है, but you have to query it, you have to extract it, and that is how the search algorithms work. So we have introduced three things until now. Knowledge का एक broad definition लिया हमने. We have understood what is internet and what is World Wide Web. Let's move ahead. Web and knowledge. These two words, web and knowledge. So what is a knowledge actually? Knowledge comes to you in two things, a perception and a reason. That is, you think about knowledge, you perceive the knowledge, you see something. That is what we humans do. We see something. Internet does not see something. The images are uploaded on internet. That is how internet can see. That is the example of how internet can perceive. Or the blogs written, essays written, articles written, everything that is written and which is termed as authentic. That is how internet perceives the world. There is no other way internet can see the world. Of course, CCTV camera networks are, but then knowledge has to be added along with those graphics. Another thing is reasoning. Reasoning is a thing where you share the knowledge and generate a new knowledge. Okay, if there is a different paragraph written about jungles, and then there is a different paragraph written about elephants. So by reading these two paragraphs, if the algorithm is able to deduce, मतलब कि वो conclude कर सकता है कि wild elephants live in jungles, then that is reasoning. But from two very different items of text. अब ये text होना जरूरी नहीं है अभी. Until now we are doing very good text search and even image searches are possible. But if there is much more information left out, the knowledge grows slowly. So we can take the help of IoT to generate that knowledge also, because until now you don't have that knowledge. So coming back to this one, perception and reasoning, these are the two things how the knowledge can be generated. So how does it work? We write good algorithms. We means we the engineers, the computer scientists, जो भी लोग काम कर रहे हैं behind the browsers, search engines, everyone. And they have outcomes from it. They advertise the things very nicely. And because of searching the values based on user experience, user is happy and they gain the money from advertisements. That is why Facebook is very keen to find your friends so that you use the Facebook more, so that they can advertise more. Leaving out the Facebook, it is with every advertising agency. So simple text lookup, ये हम कब से कर रहे हैं? From the times when search engines started, we are doing the simple text lookup. मतलब पूरे वर्ल्ड वाइड वेब में से जितनी भी वेबसाइट्स हैं, from that very efficiently the text is marked out and you can come up with the searches that are very efficient also based on the user experience. So if the website was very important for other users, it will be important for you. Based on that and based on your searches, you get the recommendations. And this is simple text lookup. You search a name and you get the search results. Data mining, आप structured या unstructured data हो उस पे algorithms run कर सकते हो. You can mine the data. It is a total different thing. But we are discussing about these topics because they work with web and knowledge generation. Knowledge is generated in all these aspects. AI is used by simple data mining. Using simple data mining is not AI. But when you include AI, the algorithm itself learns that how knowledge can be generated. Machine learning algorithms, they are run on even small things like identifying a character from text. अगर आपके handwritings है, handwritings को भी identify करना है किसी alphabet में, then you use machine learning. So machine learning is a part of AI. I should not have mentioned it separately here, but now we have to, because you can use machine learning algorithms by using services like TensorFlow, or simply आपके cases or data upload करके you can train an algorithm. And even students are doing this. So that is why it is worth mentioning separately. Although AI is a very vast field, ML algorithms are a part of it. And then you have decision support systems in large enterprises like airlines or something. So you have systems that generate knowledge, take decisions for you, whether you should do certain financial transactions or not, or take strategic decisions or not. So those are DSS. It is also a very different field. So web and knowledge, we are already doing it. We are already generating knowledge from web by writing very good algorithms. So Google search is the example. You type certain text and the text is filled up by the algorithm itself with recommendations based on the searches. That is one part. YouTube recommendations. Yes, when you go on YouTube, you have recommendations from the YouTube itself that which video you might like. That is knowledge because YouTube has the knowledge of your choices. So that is the other example. Most of the online advertisement that you get on search engines, these are algorithms working to generate knowledge, and they are generating knowledge based on your searches, data usage, and types of information that you search. So that is why I have listed. The list is very long, but these are only few to get us the understanding that how web and knowledge are related and limitedly related. So I have created this sequence of graphic images where knowledge is a part, but the knowledge is gained through perception and reasoning. Now, by this perception and reasoning, with what things does it reason? So actually the existing knowledge has to reason with other knowledge. So where do these other knowledge come from? These are the knowledges from different domains. Like there is a, if you regularly search for the websites related to technology, the search engines are going to give you recommendations regarding technology. But the technology is a domain. But if you love cars, if you love automobiles, the search engine will keep giving you recommendation about automobiles. And you also might be knowing a lot about those automobile domain, which are the good websites, which are the websites that are authenticate and give good results, which are not fake. So there are different domains of knowledge. So when those different domains can reason with each other, then new knowledge can be generated, which is already being done, but they have to be linked. So let's say the domain is software engineering domain, agriculture domain, and economics can also be a different domain. So different domains of knowledge exist on web. How do you arrange them? अभी काफी students अगर जो ये देख रहे होंगे, तो they also might have the question that, sir, you are talking about knowledge since last 8 PPTs now. How is this knowledge stored? Is it just simple text? If it is just simple text, then it is unimaginable that you can store all the knowledge in just simple text and then extract knowledge out of it. That is not possible. That is why we students of computer science and engineering at very lower semesters study very important subject called data structures. That is why we study data structures. Data structure is very important because that is how you utilize the capacity of computer to store something in a structured manner. एक database है, that is also a very structured thing. Database is structured, but data structure is an even lower term than that, कि वो smallest unit of data को structure कर देता है. So we can imagine, as a computer science engineers, we can imagine that there must be some data structure where the data is stored in a very neat manner where it can be linked with other data. And then you can say that yes, if one paragraph says that wild animals live in jungles, and there is another paragraph that says jungles have many animals like these ones, then now by combining these two paragraphs, we can make an algorithm that can give us the result that wild animals live in jungles without giving the computer any prior knowledge. We already know that. We can tell it easily, but we want the computer to tell it, and that can be done. That has been done. But for that, the knowledge is a very broad term. Knowledge is not data. We have to arrange the data in structured manner. We'll see the examples for it. And the answer to your question is, sir, ये आप knowledge की बात कर रहे हो, how are we going to do it? So one of the techniques or one of the things that you should know that exists, जो काफी students को नहीं पता होता है, and of course it is a knowledge that is not shared at bachelor's level, but there is something called linked open data. I will read it out. Linked data structure is a structured data which is interlinked with other data, so it becomes more useful through semantic queries. It builds upon standard web technologies such as HTTP, RDF, and URI. So HTTP is the protocol, hypertext transfer protocol. That is how the whole web is connected. So web initially was एक paragraph है, उसमें कोई word है, and on that word you can give a hyperlink, and that hyperlink can take you to another website. So a set of information is provided to you, and if you want to extend your search, you click on the hyperlink and you can go to the other website. That was internet, that was World Wide Web initially, that every information, if to be extended, has the link, and from that website also you can get back link to this site. So HTTP, जो Tim Berners-Lee World Wide Web जिसने start किया था as a founder of web, so it was based on HTTP, hypertext transfer protocol, कि दो browsers के बीच HTTP में browser और server HTTP में communicate करेगा. So technologies such as HTTP, the other is RDF, Resource Description Framework. We'll come to that. And URI, Universal Resource Identifiers. So these technologies can be used, but rather than using them to serve web pages only for human readers, it extends them to share information in a way that can be read automatically by computers. Part of the vision of the linked data is for the internet to become global database. So you can Google search and you can use the information or the result for yourself. But can your refrigerator do it? Can your car do it? That is the question. Let's take an example to boost up your curiosity. Take an example that after 20-30 years, it will be possible that every car is connected. So every car comes with a Bluetooth or a Wi-Fi connector that keeps uploading data to the manufacturers कि उसका कौन सा पार्ट कैसे बिहेव कर रहा है, उसका ऑयल का टेम्परेचर या डेंसिटी या विस्कोसिटी क्या है, उसके टायर्स का कंडीशन क्या है. सो एक स्पेसिफिक डेटा स्ट्रक्चर होगा या फिर स्ट्रक्चर्ड फॉर्म ऑफ इंफॉर्मेशन होगा जिसमें मैन्युफैक्चरर को या दूसरे व्हीकल्स को अवेयरनेस रहेगा कि ये व्हीकल कितना अच्छी या बुरी कंडीशन में है. Now, if all the cars, all the vehicles in that way are connected, why do humans need to take care that what is the condition of the car? As soon as the car realizes that in certain temperature areas, okay, in certain areas with hot temperatures, तो जितने भी cars हैं वो hot temperatures में चलते हैं, they keep uploading their data and temperature data also. तो उनके कुछ parts जल्दी खराब हो जाते हैं. So that knowledge is with the network. कौन से उस कार के नेटवर्क के पास. That knowledge is with the network at the level with the user. जो cars के पास knowledge है. The cars exchange the knowledge, of course, by using the technologies like HTTP या कोई भी other protocol. And the cars learn by themselves that in high temperatures this part will wear out soon. ये part जल्दी खराब हो जाएगा. So before going to the region of those hot temperatures, वो कार ही खुद मैन्युफैक्चरर को ऑर्डर करता है कि my part is worn out, so I need this part. Please order it. Provided the user has given the permission and everything. सबको ये permission देना ही पड़ेगा. जैसे कि इस वक्त तुम लोग मोबाइल फोन के साथ करते हो, तो मोबाइल फोन gets the update and you update the phone. You will also update the software of your car or any other machine like a refrigerator or the whole home operating system, that also you can update. But then here, focus on these things. It extends them to share information in a way that can be read automatically by computers also. So we are not talking about a simple search where a human can search the data, search for information, and human can get the information. That is being done. But the time requires that the machines communicate and machines ask for the information, then they get the information. And then they can take decisions. So that is why this linked open data, you can search it by yourself later on if you are enough curious. Then you will find that lots of efforts are made to link all the data. We'll see a few images and a few websites for that also. Now this image is an example of linked open data. You can see this image on Wikipedia also. And this linked open data is a structure for linked data of Wikidata. And all the dots here are the knowledge from different domains. If you can read, I will read out. The yellow dots are for life sciences data. So these small round dots, they have a lot of data inside them which is linked to the other data. And the connectors here, they connect the data from different domains. So the different domains that I can read out here are life sciences, publications, cross-domain, government data, geographical data, linguistic, media, social networking, and other things. So this is the real image actually. It is not just a made up image. This is actual linking of data that has been done so that knowledge can be generated. Talking about linked open data again, Tim Berners-Lee himself outlined 4 principles of linked data in 2006. Tim Berners-Lee founded he did something that was very important. He is a very important person of this century actually. Tim Berners-Lee in 1989, he did something that was later called World Wide Web. He operated a website from a browser and then he connected the contents. That's what he did was very simple, but he did was very genuine. And using the technology at that time, he changed the world. Okay, so again in 2006 he proposed something like linked data can do wonders, and he gave 4 things that first URI to name the things, universal resource identifiers to name things like I myself am a thing, your laptop or a phone is a thing, and everything has a property, and that property again can be a thing, like the software of your phone, or the laptop has a webcam, so the thing has a thing itself, and that is how everything is connected, because laptop has webcam, keyboard, speakers, hard disk. So all these parts are connected to one thing, that is a laptop. Then laptop again is connected to me because I am the owner of this laptop. That way we can understand the things are connected. But the first part is URI to name the things, the universal resource identifier to name everything. There is a laptop in whole world. So in whole world the laptop has to be identified as a thing. That is a portable computer that everyone can take with themselves that way. Use HTTP URI so that these things can be looked up. HTTP URI से आप आइडेंटिफाई करोगे यूनिवर्सल रिसोर्स आइडेंटिफायर से, वो URL नहीं है, वो आपके वेबसाइट का जो URL होता है, that is not URL, it is URI. So using URI you can locate that what this thing refers to, that is URI. Provide useful information about what a name identifies when it is looked up using open standards such as RDF and SparkQL. RDF is resource description framework and SparkQL is a query language to query those framework. जैसे कि पहले का क्वेश्चन हमारा था कि how is knowledge stored? What is knowledge? So you need to query that knowledge. अगर एक बार knowledge generate हो गया तो आप उसको question भी पूछोगे. So just like the SQL language is for databases, SparkQL is for the RDF query language. Resource description framework में आप query करोगे And those queries are also simple, like ABMS queries. You can find those examples. The fourth point is refer to other things using HTTP URI based names when publishing data on the web. So एक बार knowledge is there, you again want to publish a knowledge, then refer to other things using HTTP URI. By doing these four things and developing technologies for all these things, Tim Berners-Lee suggested that linked open data is useful for generating knowledge and for doing this, to share information in a way that can be read automatically by computers. That was the vision, to become a global database without having a single database. Database में एक database server होता है, उसके files होते हैं, उसका एक username password होता है, उसको आप query कर सकते हो. That is what a database is. But a global database where the structured informations are stored and you can query that structured information and gain knowledge out of that is yet not made. तो उसका कोई standard भी नहीं है. People are trying to develop it. It is a matter of research right now. Lots of people are trying. It can be done. It will be done in near future. So, describing RDF, resource description framework. So the first step of the question that you have in your mind, that how is knowledge stored? So this is one thing, a small part in a way how a knowledge is stored practically, which is resource description framework. किसी भी चीज का the subject, predicate and the object, that is how the things can be related. Subject, predicate and object. ये सिर्फ तीन चीजों से, like me and my pen. So how the pen is the subject, pen is the object, I am the subject. So what is the relation between us? I am the owner of this pen. That's it. That is the relation, right? A tire with radius 15 belongs to a small car. So small car and tire are related in a way that that small tire belongs to that car. So every object in this world can be related to other object using only these three triples. And when you have collected millions and millions of these kind of triples for all the objects, you have a linked information. So RDF is the smallest unit of how the RDF database stores the knowledge. There are other representations also. This is one of them, and popular also. RDF is a family of World Wide Web Consortium specifications, originally designed as a metadata model. It has come to be used as a general method for conceptual description or modeling of information that is implemented in web resources using variety of syntax, notations and data serialization formats. Data serialization क्या होता है? Data serialization आपको चाहिए जब आप एक ही information को क्रॉस प्लेटफॉर्म ट्रांसफर करना चाहते हो. लाइक आप पूरे आपके स्टूडेंट डेटाबेस में व्हेन यू हैव द स्टूडेंट रिकॉर्ड, तो यू कैन पिक अप द स्टूडेंट रिकॉर्ड, कन्वर्ट इट टू बाइनरी स्ट्रिंग एंड देन ट्रांसपोर्ट इट. तो पूरा बाइनरी स्ट्रिंग ट्रांसपोर्ट होगा, लेकिन जहां वो रिसीव होगा दैट प्लेस कैन आइडेंटिफाई इट एज अ स्टूडेंट रिकॉर्ड. So that is what you mean by serialization. You serialize the details of that object, and when you receive it, you again receive the whole object and all this information related. So that is data serialization. If you just to clear out the students who don't know anything about it. Okay. So web resources पे resource को describe करने के लिए RDF use होता है. Okay. Let's see some examples now. For examples, I want to show you that how RDF can be made. If I have the permission, I can show you the live example by stopping the presentation and then present again and my entire screen. Okay, and then yes, this is the example of linked data. I hope I'm sharing the same screen now. Stop presenting. Present now. Okay. Yes. This image is how the various databases, data sets are linked. So DBpedia is a linked open data connected to other data sets, and that are medical databases, science databases, publications, open library, ORILI library, which some of us can identify very easily. But these are libraries for everything. And if we see the varieties, the green ones are the publications, life sciences, cross domain, social networking, geographic, government, media. All these data are connected. And this is not just a simple graphical representation. It has come up, this graphical image has come up after linking these real data sets. So the example comes from UK. So the UK government has linked all the public data sets, other libraries, and you can find it very easily on internet. This diagram can be found on internet, and if I click on one of these links, it will take me to the database or the data set of this particular set, which itself will also be very large. So I just wanted to share this, so students don't think that it is just a theoretical part. It is a very practical part. I'll stop presenting the screen now. Again, I will present my PPT. Okay, moving ahead, we saw the example of a linked data set. Now we come to the other part, that how to structure the linking. How to structure the linking. So one part is ontologies. Now I am sharing the knowledge that I have. So it is possible that a lot of students might find it very new or something that they have never heard of. But these are the real things that work behind structuring the knowledge. Okay, so I am aware that I am presenting a webinar to Polytechnic College, but I hope a lot of wide variety of students and listeners are here. Even my colleagues, faculties are listening to this. So this is what I have read about in recent years. So ontologies, an ontology encompasses a representation, formal naming and definition of the categories, properties and relation between the concepts. So entities that substantiate one, many or all domains of discourse. So ontology is a way of showing the properties of a subject area and how they are related by defining a set of concepts and categories that represent the subject. तो थोड़ा complex हो गया, लेकिन ontology is something that how do we communicate? Ontology का example देना चाहता हूँ मैं, that how do we communicate with each other? How do you know what I am speaking is what you know? Because of the language. We share the same language. So मैंने अगर आपको बोल दिया कि there were very dark clouds here and it was raining heavily. So you understand completely what I said. Because you know what are dark clouds. You also have seen dark clouds. And you also must have seen heavy rains, because we are of course of the same age maybe. तो you also might have seen the rainy seasons. लेकिन अगर मैं छोटे बच्चे को ये सब कुछ बोलूंगा तो he won't understand because he does not understand what are dark clouds and heavy rain because he don't know or he has not collected the knowledge of the mapping between dark cloud and heavy rain. You have, so that is why you can understand. So that is how everything works. If someone tells you something and you have the idea of how the things are connected, you automatically gain that knowledge. If not, you cannot. So what is required is, if the two knowledge domains want to share the information, they can share the same ontology so that they can understand what they are talking about. All right. So if you are talking to, that is why talking to the people from same country is easier than talking to the people of other countries. Because for you, a very nice festival is correlating definition to the same countryman rather than the other country. So ontologies is about that. And there is another thing called web ontology language, which is a family of knowledge representation of language. तो ये language है, web ontology language एक define किया गया है. You can research on that also, and they give the formal definitions of how a language can be created. Ontologies को define किया जाता है और create किया जाता है. I have to conclude this in 10 minutes, so let's go on with an example again. Let me show you an ontology. This is an ontology, if it is visible to you. Is it visible to you? No. Start presenting, present now. Window. Yes. This is the example of ontology. If you can see this, we say we have created a thing called road, and that thing is a subclass of, it can be panchayat road, it can be national highway, it can be state road, it can be state highway or a municipal road. And this is how the graphical representation is given. And that road is what vehicle moves on. So what is the relation between vehicle and road? So vehicle moves on road. This is the ontology. This is a graphical representation of the ontology that is created. And what is the extension of this ontology? The extension is OWL, that is web ontology language. Right? So how do we create this web ontology language? I have created that on my laptop. So I have created it here. So this is how I have created. And if you can see my screen, this is the municipal road, national highway, panchayat road, state highway and state road. This is how I have defined an ontology and I have created the graphical representation of it. So इतना सारा क्यों करना पड़ा? Because if I want to upload a knowledge regarding roads and vehicles, I have to tell the computer, or I have to tell the internet that what my knowledge is about. Okay. So let's quickly go to what is cloud, fog and edge, which is where we are going to implement our solutions. So cloud is a very popular thing. You know what is cloud. Cloud is a concept. उसमें सब कुछ होता है. तो whatever you upload also goes to the cloud. So it is a collection of servers, networking devices, everything. That is cloud. So in cloud, at least you are sure that आपका data अचानक delete नहीं हो जाएगा. So services are provided by cloud. So cloud concept में ये है कि services are delivered and user over the internet and are paid for by the cloud customer. So जितना भी हम सर्विस के लिए पे करते हैं उससे क्लाउड हमको सर्विस देता है। डिवाइसेस क्या है क्लाउड के? वेब सर्वर, स्टोरेज सर्वर, नेटवर्क डिवाइसेस। जो छोटे छोटे नेटवर्क डिवाइसेस, दे आर आल्सो पार्ट ऑफ क्लाउड। एंड द क्वेश्चन लास्ट वन, इज इट द हार्डवेयर दैट मेक्स द क्लाउड? क्या हार्डवेयर क्लाउड को बनाता है? नॉट अगेन एग्जैक्टली द राइट आंसर, बट द क्लाउड गिव्स अस सर्विसेज व्हिच आर इंफ्रास्ट्रक्चर एज अ सर्विस, प्लेटफॉर्म एज अ सर्विस, सॉफ्टवेयर एज अ सर्विस। तो मतलब आपको सिर्फ हार्डवेयर यूज करना है नेटवर्किंग का और उसका स्टोरेज का, तो दैट इज इंफ्रास्ट्रक्चर। देन प्लेटफॉर्म, तो यू आर यूजिंग द होल प्लेटफॉर्म, क्लाउड प्लेटफॉर्म एज अ सर्विस, तो आप उसका सारा प्लेटफॉर्म यूज करते हो बेस्ड फ्रॉम ऑपरेटिंग सिस्टम से लेके सब कुछ। सॉफ्टवेयर एज अ सर्विस, आपको स्पेसिफिक सॉफ्टवेयर के लिए पैसे देते हो और सिर्फ सॉफ्टवेयर लेते हो ब्राउजर या इंटरनेट से। एंड ऑल दी हाइब्रिड वेरिएशंस, आपको आई थिंक सब कुछ हाइब्रिड ही लेते हो व्हेन यू टेक ऑल थ्री एंड से दैट मुझे अपना वेबसाइट होस्ट करना है, एंड यू आल्सो नीड स्टोरेज डिवाइसेस, okay, and also need software to maintain that. So mostly we take all the three of them or combination of one or two. So that is cloud. We are discussing the section of cloud, fog and edge. Now there is a concept called fog computing. तो fog ऐसे होता है कि fog is not cloud, cloud की तरह ऊपर नहीं होता है, fog थोड़ा नीचे होता है जमीन के नजदीक में, इसलिए मैंने the diagram is for the concept of fog. So fog is near to the earth. Fog says that fog has the devices. वो exactly cloud नहीं है, वो उतना सारा computing नहीं करेगा, लेकिन वो होता है। There are devices that connect your phone to the cloud. So those devices can be made powerful to do some computation, ताकि सारा computation cloud पे नहीं जाए। That is the concept of fog computing. So architecture अगर देखें तो there can be many images found. This is one of them. So overall on the top there is a cloud. The fog computing layer where there are switches and hubs and routers, wireless devices, wired devices, every other network device, temporary storage के लिए भी devices होंगे. So that is a fog layer. And at the lowest level there are our computers and mobile phones. So that is the last layer. So computation can also be done at fog layer. That is the concept of fog computing. Fog computing devices are the ones that are listed: industrial controllers, switches, routers, embedded servers, cameras even. So cameras, if they have a small processor, they can be made enable to compute small data, detect a face, detect an animal, detect an intruder, and work as an alarm system also. So these are the concepts that are coined. इस पे काम होना चाहिए, उस काम के सक्सेस रेट पे then new products can be launched, new devices can be made, या फिर research is for to check if that can be done or not. Okay, so fog computing devices का इतना possibilities है. Now coming down to different concept called edge computing. Edge computing is a distributed open IT architecture that features decentralized processing power, enabling mobile computing and Internet of Things technologies. In edge computing, data is processed by the device itself or by a local computer or server rather than being transmitted to a data center. That is edge. मतलब आपके क्लाउड का और नेटवर्क का लास्ट पार्ट इज एज, like your phone on which you might be listening to or looking at this screen or attending this webinar. That is an edge device because it has sensors, it has the user, it can generate data and it can transmit data, but it is a bit powerful. आपका कंप्यूटर का प्रोसेसर always busy नहीं होता है. That processor can be utilized to do some computing, और आपका फोन काफी computing करता है and that computed knowledge is generated. So your phone computes a lot of things. फोन से काफी कम पावरफुल डिवाइसेस भी एज कंप्यूटिंग के पार्ट हो सकते हैं. दे कैन कोलैबोरेट, दे कैन कम्युनिकेट एंड कंप्यूट द रिजल्ट्स, और फिर जो रिजल्ट्स होते हैं वो अपलोड कर सकते हैं सो दैट वी कैन रिड्यूस द ट्रैफिक टू द क्लाउड. और क्लाउड पे अननेसेसरी बर्डन नहीं पड़ सकता है if computing is distributed. That is edge computing concept. This is another image. Also, the source is mentioned here. You can also find it. So edge computing says that there is a cloud on top, the middle layer devices, and there are the edge level devices, which are sensors, very small sensors. Like take an example of agriculture, where technology can be implemented, and in small spaces, farming has to be done to grow vegetables and other valuable vegetables, let's say, valuable items of consumption. So in that you have a small plant that controls the humidity and temperature and the nutrition and everything, even CO2. So you can implement sensors. So those sensors collectively they give the data to one part that can be called a data sink. तो सारे sensors का data एक छोटे से device पे आता है, but that device can compute. So that device can compute and take decisions and change the valves or turn on the motors, turn off the water, all that. That computing is possible. So that device is taking decision. So it is not necessary that beyond that edge, cloud has to be involved. So if that kind of agriculture or farming can be done on large scale and all those edge devices that take the data from sensor can communicate, they can generate knowledge. And that is what the concept or the core part of today's webinar was, that those edge devices can be made to communicate and new knowledge can be generated. But only when you have structured the data, when you have identified the ontologies so that they understand each other. So that you have the ontologies. So these are the examples of edge computing devices: sensors, actuators, data sinks for sensors, switches, routers, and mobile devices. And applications are many. The number 6, predictive maintenance. आपका रेफ्रिजरेटर में सेंसर है और सेंसर ही आपके फोन को कम्युनिकेट करके बताता है कि सर्टेन पार्ट इन रेफ्रिजरेटर इज नॉट वर्किंग प्रॉपरली, सो यू रियलाइज दैट आपको फ्रिज संभाल के यूज करना चाहिए. दैट इज प्रिडिक्टिव मेंटेनेंस. अगर एक सिंपल सा व्हीकल है, कार है, उसके अंदर भी अगर सेंसर्स रेगुलरली रिपोर्ट करते हैं दैट सर्टेन पार्ट्स ऑफ कार आर वाइब्रेटिंग मोर देन नेसेसरी, देन यू कैन गो टू गैरेज. सो व्हाट वी वांट इज to understand the ontologies of each other. So the car will give the information in human readable format, but we want that that information is so structured that the car automatically can notify the manufacturer. Okay. Industrial automation, autonomous vehicles. So a self-driving car has all the intelligence in the car itself. If it starts depending on network, it is hazardous because network is not always connected. So autonomous vehicles are an example of that computing can be done on the last device. Blockchain, fog computing. Again, edge computing helps fog computing. That is why it is mentioned. Connected homes and offices, everything. So these are the applications of edge. Provided you have the knowledge structure. So where is the gap? Knowledge generation in IoT and cloud fog computing. We want that IoT devices should communicate to each other. वो एक दूसरे से बातें करें, कंप्यूटेशन करें, सीखें एक दूसरे से, राइट? ये पॉसिबल अभी तक नहीं है बिकॉज नथिंग इज स्ट्रक्चर्ड, नथिंग इज स्टैंडर्डाइज्ड कि दो कंप्यूटर्स एक दूसरे से बात करें. तो दैट इज वेरी इंटेलिजेंट थिंग कि सर ऐसा तो हुआ था लेकिन होने नहीं दिया गया, ये सब कुछ. बट दैट इज नॉट अबाउट, we are not talking about that. We are not talking about AI communications. We want that limited communication for the better of the machines. Like one machine can talk to another machine, and based on their combined knowledge, the decision can be taken that why those machines are working in good condition or bad condition. That is one. So IoT devices can interact and reason and generate new knowledge. That is the topic. Again, the diagram for edge computing. The devices like industry parts, cars, they are at the last level. They are the sensors. उसके ऊपर edge है, and then the cloud data centers. So future holds these possibilities, and you all as engineers need to work on that. I don't know you all who might be listening, but here I conclude myself today with these discussions. All the images were taken from internet and the sources were mentioned. So I conclude my webinar here. Over to Komal madam.
Sir. Sir, one question from student is that what is the real application of this web ontology? Any real-time application of web ontology?
Yes. Very nice question. There are real applications of web ontology. Ontology has to be made. It is a data science thing, first of all. Once you make the ontology, and I can also give you the example. Let me share the screen again. I will share one thing from you. Observable property, semantic sensor networks. So if you go for semantic sensor networks, SSN. So it is a very popular topic for research also, that SSN ontology is defined, semantic sensor network ontology is defined. Now assuming in next coming years, there will be sensors in almost all the equipments that you use right now that don't have sensors. Okay, अभी जिसमें sensors नहीं है उसमें भी sensors होंगे, तो sensor के कुछ properties हैं, those properties have to be defined and that is why you have to define the ontology for that. तभी आप उसको standardize कर पाओगे, because if you don't have the ontology, it will be difficult to identify certain sensor network in unknown conditions. जैसे कि स्मार्ट सिटी का एग्जांपल ले लो. स्मार्ट सिटी का एग्जांपल लेते हुए, स्मार्ट सिटी में काफी सारे ऑब्जेक्ट्स होंगे जिसमें सेंसर्स लगे होंगे, जैसे कि डस्टबिन है, और जैसे कि वाटर पाइप्स हैं, जैसे कि इलेक्ट्रिकल ग्रिड है. इलेक्ट्रिकल ग्रिड इज द फर्स्ट थिंग, इट इज वेरी इंपॉर्टेंट. तो उसमें सारे में सेंसर लगे होंगे एंड दैट सेंसर्स डू सर्टेन थिंग्स. तो क्या थिंग्स करेंगे? व्हाट इफ यू चेंज द सेंसर्स? If you want to change the sensors at random time, random level, that sensor has to be programmed with that ontology in which it has to transfer the information or talk to other sensors. That is why ontology is important. That is why it has practical applications.
Okay, sir. So, sir, here we conclude our session. We complete this session. So, thank you very much for the wonderful session. The source of knowledge that we get from you today will help our students in future. Thus, on behalf of IT Department, Parul University, I extend my sincere thanks to you, sir. So, once again, thank you, sir, for this informative session.
Thank you, ma'am. Thank you for the opportunity. Thank you all. I hope I am clear about the question and I am available if you still have doubts. Okay, the particular student who asked that question.
Okay, sure, sir.
Okay.
Okay. Have a good day, sir. Bye, sir.
Thank you, ma'am.